Alrighty, let's get started. So, we are at week 2 and 46. Week 1 was basically just reviewing a few things from CSIS45, how to install things and get it going. And one new thing, I posted my office hours. Since we're week 2 already, this is basically what time you can find me, anything in green. So it's usually until 1:10, 1:15 on Monday through Thursday. And if you need extra help, send me an email or whatever, we can arrange something else. So, again, week 1 was just reviewing C++ things, mainly arrays and pointers, among other things. And this week we're going to start with your first, introduction to data structures. I already mentioned to you what data structures are and what abstract data types are, maybe. So do you remember? What's the difference between abstract data type and data structure? Okay. Data structure is, data structure, one example of a data structure is an array. The data structure is the computer science or the programming representation of a real world thing. Like if we have a line of people come from the end and leave at the front, right? If you have a stack of plates, you always put the plates on top, right? Or the last plate goes on top, and then if you start washing them, the first one you wash comes from the top. So these real world examples are examples of abstract data types, okay? And in the abstract data types, we focus on how things work, really. And the data structure is the actual computer science program, how we model this thing into our programs using whatever programming language we're going to be using. So that's basically in a nutshell what these are. And there's a couple of PowerPoints in there, chapter 1 from 2 different textbooks. So I'll just go through them real quick. One other thing that we're going to do today is we're going to play a little bit with header files. And I'll show you what's if and def and how to do all that good stuff. And I'll tell you more about that when we get to it. So let's have a look at the first one. First link on top, chapter 1. Okay, that's from this book from Niehoff. Right, that's one of them. Okay, so basically, again, difference between the abstract data type and data structures. The abstract data type, you describe the functionality and of some real world problem, and the data structures is, implementation of this functionality into our programs somehow. And some examples of data structures, you mentioned arrays. Yeah, arrays. There's also vectors, there's lists. We're also going to talk about linked lists, stacks, and queues. I already kind of mentioned. There's also trees, there's graphs. Okay. And this PowerPoint kind of goes over, a little bit about what an array is. So you should know what this is already. Okay, it's basically just a bunch of numbers stored, or a bunch of data stored in memory sequentially. Okay, what an array is it really is just a pointer to some starting place in memory, and then if it is, let's say, a double array, then every cell will be next to the adjacent cell off by 8 bytes, right? So it's 8 bytes plus 8 bytes plus 8 bytes. That's the offset of these addresses, and that's basically an array. There's also 2-dimensional arrays, right? 2-dimensional array is just like an Excel spreadsheet. You have rows, you have columns. It's a table. Okay, we didn't do a whole lot of 2D arrays, but just so you know, there are 2D arrays, there's 3D arrays, there's 4D arrays. Okay. So vectors. Vector is like an array. except it can expand its size, right? So if you need more, let's say you start with a vector of 4 things, you need to add a 5th one, it will automatically expand its size. So a vector is an array that changes its size. The only problem with vector is that it will change its size, kind of like doubling its size at times. So let's say you start with a vector of 4 things and you want to try the 5th one, it will double itself to like 8. So sometimes it might expand to bigger than you want it to. Okay, take up too much memory. Linked lists are something that we're going to be doing too. And basically, I have to introduce objects. Well, we'll do that. And basically what you have is you have a class, you have an object, and inside of that class or object, there's a pointer to itself. So let's say I have a human class, and inside of that human, I'm going to have a human variable. So it's like it will have a variable of its own kind. And what that variable will do is it will allow you to make one object equal to another object. So basically it's like the end of one is connected with another one, and then at the end of the other one is connected with another one. You have regular linked lists where it's a single linked list, which you kind of see here. This is the first one that I'll introduce when we get to linked lists. And basically you have a starting place, something that points to the first object or link, and then each of these objects or links points to another one until you get to the last one, and the last one points to nothing, null. Okay, so that's a linked list. Deleting and inserting links is actually a lot faster than doing that with arrays. When you have an array of like 1,000 things and you try to insert in the beginning, you would have to shift all 1,000 things one to the right. If you're trying to delete from the beginning, you're going to have to shift all 1,000 things to the left. But if you have a linked list, you can go anywhere you want. You can go in the beginning of the linked list, and if you want to remove a link, you just repoint one link. So let's say you have the head pointer. I'm trying to delete the first link. I'm just going to repoint my head pointer to the second link. If you want to delete some link in the middle, I delete the link that I want. Well, first I repoint. So this is one of my links, which used to point to this one. That's the one I'm trying to delete. So all I have to do is basically just repoint this one to this one here. It's just one operation. Question?
So I understand this is like a daisy chain, but when you first create this, it doesn't allocate contiguous memory for the entire vector, that you're just pointers to each.
Yes, then that's the advantage of a linked list, because it doesn't, you only occupy as much space in memory as you need to, right? Unlike the vector, which just, you start with 4, then it goes to 8, and maybe 16, and then you get too many, things in memory that you don't really need. Okay, and then an algorithm for inserting a link, basically similar situation. You have originally this one points to this one. What are you trying to do? You're trying to insert something in between. Well, first what you're going to do is you're going to grab this new one and you're going to point it to the place where the old one was pointing, right? Now you're going to have 2 pointers, 1, 2, and then you just tell this one now points to this one. And with just 2 simple operations, you created, an insert of a link. And printing linked lists, all that good stuff. So for linked lists, one of the disadvantages for them is that you have to go through every element. Let's say you're trying to go to the last one. There's no way for you to jump directly to the last one like you would with an array. If you have 1,000 things in an array, you tell it, go to index 1, 999, and it goes to the last one. You can't do that in a linked list. You have to start from the beginning, go to the second, third, fourth, one by one, hop through all of them until you get to the end. So that's kind of sort of the algorithm for printing. You basically go through one and the other. Stacks, stock, the way we're going to do a lot of the stuff in this class is through arrays, by the way. Okay, so how we're going to do a stack? Well, we're going to start with an array. And it's basically just an array where you're restricted to only adding things on one side and removing things from that one side. That's it. And then when we get to a queue, All right, not sure what Q is, but and by the way, what's a stack? It's basically like a stack of plates, right? You put the last plate on top, remove it. Pest dispenser is another example of a stack, right? You add at the top, you remove at the top, okay? And we'll be doing that with just the good old regular array. All right, so the different operations of a stack, right? Putting things on top of the stack is called push, right? Pushing things on the stack, and then removing things from the stack is called pop. And again, don't worry, we're gonna get a whole week dedicated on stacks and queues. We're gonna have like 3 weeks dedicated on linked lists, so you get comfortable with them. Queues, again, queue is just basically another word for a line of people, right? Or I don't know, that's a queue. So last thing comes at the end, and the one that came first leaves at the beginning. Okay, and again, all it will be is you're gonna have an array where you're going to limit that array to only inserting things on one side and removing things on the other side. Okay. Circular queues. There's circular queues, there's priority queues, there's circular lists. This here is an example of organizational charts. Organizational charts are something that we can model with trees. Okay, and what's a tree? Well, it's a tree. All right, it's got roots, which is the bait. Think of it like a linked list, except the things are not linked sequentially one after the other. You can have one thing linking to multiple things at the same time. Okay, and there's different kinds of trees. This thing kind of looks like a binary tree, or like it's some kind of a binary tree. What's a binary tree? Well, you can have. By the way, these are called nodes now. I guess I'm not sure what they're called for the linked list. I guess they're also nodes or links. But anyway, you have roots. I mean, the root is the topmost node that links to all to subsequent ones. So in this case, you have one root linking to 3 different things. That's not really an example of a binary tree. Binary tree is a special kind of tree where each root or each parent, there's children, there's nodes. The nodes are the connections between the different things. So each parent has at most 2 children. That's a binary tree, and then the left one is bigger than the right. Not sure if it's left bigger than the right or right bigger than the left. Okay, but there's a special algorithm. The algorithm for inserting things into the tree is written in certain way, just like we did with the queues and the stacks. You can only insert, if we're going to be inserting something, you check specifically where it goes. So the arrangement, the default arrangement of tree can change. Okay, and based on these different arrangements of the trees, we call them different things. There's also a heap. Heap is a kind of a tree where the highest thing is all the way at the top. When you have a binary tree, sometimes the lowest thing is going to be all the way to the left. The highest thing is going to be all the way to the right, which makes it easier to search through the thing. Okay, and we can also create trees with arrays. By the way, we're going to do that. Okay, I'm going to show you how to do a tree with an array. A lot of these things there's going to be, oh, here's how we can do this with an array. Okay, now we're going to change this to you can also create whatever data structure we're doing using linked list if you want to. Okay, or pointers. So binary tree, all right, and they don't tell you a whole lot in there. Okay, but basically this is a picture here showing you that we can do this kind of stuff with an array, and we are going to do this. And we can also do a binary tree or a tree using linked lists. Okay, so you can use linked lists, you can use arrays, and that's why I spend a lot of time on the topic of linked lists, because it's important. Software development, right? You start with some kind of requirements, then you design the system and the software units, then you implement the code and test the units and integrate the units. Okay, somebody was asking me this question, like for the Java class, the Java data structures. How do I write these things? And just Don't write the whole thing at once, obviously, right? You start little steps. First of all, you want to break down the big problem into little sub-problems, right? Each of these sub-problems goes into a function or a method that we're going to be calling it in this class. Then you solve each of these sub-problems, right? Those are your units, whatever you want to call it, modules, procedures, functions, methods, same thing, okay? And then you start building the puzzle together. You start putting up all the different pieces, all the different units together, and then that's the integration part. Make sure that they all work together, and then if the whole thing works, you test it, okay? Or test that the whole thing works before you release it to the customer, okay? And you don't necessarily jump from one phase to the other phase. A lot of times you have to go back. You're all the way at the deployment stage, but you got to go back and modify your system requirements because the customer doesn't know what they want. Maybe they added something extra. All right, some difference between computer science courses and real world. Well, the computer science courses, or at least so far, in the community college system at least, since you're starting, we can only do so much, right? A few hundred lines of code, right? Maybe if you take one of my classes, maybe there's going to be a project with like 500 lines of code, right? Somebody's written one of the tic-tac-toes in the Java class with 2,000 lines of code, but you don't have to, right? The best tic-tac-toe in the Java class was written by this math person, and she only took like less than 200 lines of code. Marissa killed it. She did an AI for the tic-tac-toe with like 200 lines of code. Blew my mind. Okay? So anyway, but the real world problems are, much larger problems than, tic-tac-toe, and so thousands and thousands, maybe millions of lines of code, okay, depending on what project we're talking about. So the problem specifications or requirements or the contract between you and the customer, okay? What is the purpose of the thing you do? What are the preconditions? What are the things that need to be true before you do this? And what are the post conditions? What are the things that are going to be true after you've done this, whatever this is, okay? And the object-oriented design. So in C++, we didn't talk much at all. In the first C++ class, we didn't talk much about objects. Okay, that's why I recommend taking Java before you get into data structures. But if you haven't taken Java, or if you're taking it right now, what's an object? Well, object is, imagine everything we've done in the 45 class. We had functions, we had variables, we had the main. Now we're going to add something else called a class. So everything we've done in CSIS45 is going to be bundled up into a class. And I'm going to show you plenty of examples of that stuff next week. Okay? But basically we bundle up everything into some kind of a named entity called an object. Objects are created from classes in Java and C++, and C doesn't have classes. Python also has classes. Okay? And so every object has some kind of properties or states. Right? So let's say you have the dog object. The dog object is going to have the property age or name or something like that, right? So those are basically the variables of what you've been creating, okay? So those are the states of the objects, and then the way we change these states is using functions, except functions, when we put them inside of classes, are called methods for some weird reason, okay? If somebody asks you what's the difference between object-oriented programming and procedural programming, you can try to Google it, and there's going to be a whole lot of very long answers that don't explain really what it is. Procedure-oriented language is basically you just have procedures, also known as functions, just on their own, right? And without being grouped inside of a class. That's a procedural language, right? Once you put all this stuff inside of a class or inside of an object, now it's an object-oriented programming. Okay? So again, each object is going to have some kind of properties, which are the variables, which can be modified only through its actions, which are also known as the functions or the methods. Okay? And we'll do this. And this here is the UML diagram, which which is basically the universal markup language or something like that. And it is a way for you to graphically represent objects. And one thing about objects is you can inherit properties from one object to another object. Okay, which I don't know if I told you this, Chuck, but what is the object-oriented way to becoming wealthy? Inheritance. You've heard that joke before. All right. So yeah. And then there was also another joke about objects. Was why did the programmer lose his girlfriend? Because he treated her like an object. Okay. Everything in computer science is an object, right? You're an object. I'm an object. The table is an object. You know, objects have properties and actions. Even if you're a rock, you have some property. Maybe it's a weight, right? Or color or whatever. And you can change that. Anyway, so objects are basically the containers. Okay. Algorithms. You should know what algorithm is, right? Step-by-step instructions to solve a problem, right? Recipe of sorts. And there's different kinds of algorithms. There's structured and unstructured algorithms. I guess this page shows you the difference between one and the other. On the left is one that uses go-tos, and the other one uses whiles, right? So technically speaking, I don't ever want to see go-to in any one of my classes. If I see somebody using a go-to, it will be like 0 and rewrite, okay? Because go-tos were the old school way we did things, I don't know, 20 years ago plus, where before they realized that it actually creates this kind of a spaghetti code. If you see how like you can jump all over the place with these go-to statements, and it becomes very difficult to debug this kind of stuff, right? Something goes wrong with your program, it's hard to follow what went where. Okay. All right. And testing, execution, and debugging. Okay. And you should know pretty much what those are. Okay. I kind of talked about this already. Unit tests, integration tests, how you write the big project, you break it into little pieces, put them together, test the whole thing. Okay, there's different ways, you know, for this phase, for these different phases to interact with each other, right? Remember, you can basically jump back and forth between the different stages. Types of errors. You have syntax errors, runtime errors, logic errors, right? Syntax errors prevent the program from running. Runtime errors will happen during the time the program is running. In those, there's logic errors also. The program is running, but it's not working the way you want it to. Okay. And more on the same thing, pretty much. Okay. Again, precondition and postconditions. Okay, preconditions are things that need to be true before something happens, and postconditions are things that are going to be true after that something has happened. Okay. And yeah, usually we do this kind of stuff for functions. Like for example, if you have a function that is supposed to do something, like for example, this is a function that is supposed to find the square root of something. Right? What is the precondition? Well, the computer won't be able to do a negative square root, right? Doesn't know how to work with imaginary numbers. So the precondition must be that the x is supposed to be greater than or equal to 0. Okay? And what's the postcondition? Well, we're going to find the square root and show it. Okay? Something like that. So precondition, postconditions, important thing to have. You know, write this maybe in your functions. Question?
I'm sorry, so when you write the code, you actually, your first line should be to test the precondition.
Sure.
And then check for x being greater than or equal to 0?
Yeah, exactly. And that's the reason why, this is the reason why you want, remember when we were talking about like the object-oriented thing?
Right.
You have the variables buried inside the object, and the only way for you to interact with those variables, or in this case, the only way for me to interact with the variable x or do something with the variable x is if I have entered a positive value. So that's the reason in objects, you only want to interact with the variables through the functions. Okay, that's called encapsulation. Question?
If not, will it just be garbage, basically? Is that
It would be garbage if you don't write it. Yeah, if you don't make sure that the precondition for x to be greater than or equal to 0 is true, then it might crash. We know C++ loves to crash.
Java, it'll just automatically.
Java will give you some kind of an error.
Okay.
Java will likely give you some kind of an error.
Okay.
Yeah, but C++ is not as nice as Java. It will just,
Very cool.
yeah, it might be some weird number. It might be just crashing on you. All right. I mean, I don't even think this thing crashes on division by 0. I think I tried it the other day. It's just C++ is weird. Okay. Some people like C++ more than Java. I'm not one of them. Okay. So that's the preconditions and postconditions, basically, in a nutshell. Right, with more explanation and examples. Okay, yeah, so important, very important for you to know what are the requirements, what are the preconditions, what are the postconditions, what is the customer asking you to do. Okay, and one way to do it is using this assert function. So assert is basically pretty much what it says. You make sure that something is true. If it isn't, it kicks you out of the program or out of the function. Of course, you can use an if, different ways to do it. All right, so yeah, pre and post conditions, it's good if you have that stuff in your code, right? Every function that you're writing is the module or whatever. You have to have some kind of a comment on top telling whoever's going to be using this code, yourself most likely, why am I using this function? How is it supposed to work? These are basically the preconditions and postconditions. All right, that's the first one. And the second one, let me download that too. So that's from the other book. And I will soon start to deviate, or move away from these textbooks because they tend to overcomplicate things. Okay, they want to show you, okay, this is how we do it with the latest syntax in C++, and the syntax changes over the years. But the fundamental things that we're going to do are still the same, so I'd rather not go into details about what's the most modern way to do this. I'll just show you how it's done, okay, by removing all the complicated things. All right, so this is a little bit of the same, right? What's the object, right? I kind of told you what an object is. One thing, principles of object-oriented programming is the encapsulation, okay? And it actually has two different meanings. Encapsulation, one meaning is objects combine data and operations, right? Which is the bundling of data plus methods, right? So you have some variables and you have some ways for you to change those variables using functions or methods, okay? Another meaning for encapsulation is that the data is hidden. So you cannot change the data inadvertently by just providing, wrong numbers, right? And the way we do that is in your classes, which are the templates for the objects, you just make your variables private. Okay, you make them private, so now the outside world cannot access the variables of the object. How is the outside world going to be able to access the objects? Through the functions. Okay. Inheritance, I kind of told you what it is. And basically, properties from one object can be inherited to another object. Polymorphism means that one thing can perform multiple different functions depending on how you're using it, when you're using it. That's the polymorphism. A lot of fancy terminology. All right. Okay. Coupling is a measure of dependence among modules. So how are different functions supposed to interact with each other? How do they depend on each other? Okay. The abstraction talks is really about how you're supposed to interface with your classes, right? And the example that I like to use is the remote control, right? You don't really know how. You know how the remote control works. If I press the power button, it turns on or off. There's a volume in there maybe, right? But do I really know how it's connected or how it's interacting with the projector, all that good stuff? Not really. And I don't care, because I know that if I press the power button, it turns on or off. Okay, so that's basically the abstraction that you're supposed to provide for your functions. And basically, even for yourself, when you're using your own functions, once you've spent like a week to write something long, you just want to be able to use it after that. You're not going to rewrite the code every time. This is the function on top. I have my preconditions. This is what needs to be true before I use it. Post condition, this is what is going to happen when I use it, in that kind of form basically. And then you just use it based on these comments on top. Okay. So that's the information hiding thing that I kind of told you already. And the interface. Right, so abstract data, again, it's a collection of data and set of operations on the data. Okay, basically how things are going to work. That's the abstract data type, some real world problem that we're going to tackle. All right. So what data does it usually require? Those are the things you want to ask yourself. And what operations are we going to do on the data? It's just the usual. What variables are we going to have? And what are we going to do to these variables? Okay. All right. And then finally, we're getting to the ADT bag. ADT bag is the first data structures or abstract data type that we're introducing in this class. And it is basically just a collection of unordered things, right? Just like a grocery bag. You can fill it up with a bunch of different items. Each item can have its own name, its own price. They're not, the grocery bag is not sorted by name and it's not sorted by price. When you go to a store, they don't try to do that. Right? It's kind of like in a random order. There could be duplicates. You can buy 20 bananas in there or whatever, okay? And you can add and remove. You can add to the bag. You can remove from the bag. You can count how many things are in the bag. I guess you can go through them and add up the prices, figure out what's the total of the things in the bag. So those are possible operations that you could do with a bag. You're not really supposed to sort it. You're not supposed to really arrange it in any particular way. So it's just a collection of, possibly repeating items. That's a bag. Okay? And that's what this tells you. You can get things in the bag. You can see if it's empty. Well, one thing, you could check to see if the bag is empty. You might also want to be able to check to see if the bag is full. Right? If it's too many things, all right, call it full. And how we're going to do a bag? Erase. Right? We're going to do a bag using erase. And yeah, you can count how many times a certain thing repeats. Maybe you want to count if there's 15 bananas, right? And you can also look for a specific thing. Maybe you want to go see if you have peas in the bag, right? And of course, you might want to show all the things in the bag. Okay? And that's basically those two. Now, let's get our hands dirty with something else. So here, okay, so the next thing that I want to tell you about is about header files and how to use them and all that good stuff. Okay, and I'll tell you about my experience learning data structures. I took this class many years ago at Hartnell, and we learned it. There wasn't a Java data structures there. It was just you take C++1, you see C++2, and then C++3, and then you're done. Okay? And yes, there was a middle one. In here, we kind of go from C++1 to C++3. We skipped the 2. So I got to go in there and bundle up the object-oriented thing somewhere in the middle, which is why I recommend taking Java, where things are all objects. So anyway, the way I learned this stuff was we had to create, everything had multiple files. And, you have one program with one main, and that main has like 4 or 5 different header files, and each header file is connected with like 4 or 5 different C files or C++ files. The header files each header file is connected with its own C++ file, and then they're all run from the main. So I end up with like simple program to do like whatever, and it's got like 50 files in there. Okay, and if something's wrong with one of the files, the whole thing doesn't work, it's very hard to debug. Okay, so I'm not going to do that. Okay, what I'm going to do is I'm going to show you about header files in C++ and C files, CPP files, how they're used, how miserable your life could be if we did it, and then I'm going to abandon the header files in the C files, and I'm going to treat this as if it was a Java program. Okay, so that's my approach with this class. I'm not even going to bother with the latest C++ syntax. I'm going to show you this in a very similar way that I would show it in the Java class, because in my opinion, Java makes it easier. All right, so, but let's start with the header files and look at this stuff. Okay, so first of all, I have, a beautiful picture in there with some beautiful arrows, okay, of how you can create a project in CLine. Okay, so you open up CLine. If you are on a Mac, I have instructions on how to install this thing on the Mac. If you're on Windows, I have instructions on how to set up this thing on Windows. Right? So I'm assuming you're working on a CLine. You want to work on Eclipse, you want to work on code blocks, that's fine with me, but you're on your own. I'm not going to provide customer support for those two. Okay, if you need help, use CLine. Okay, I'll try to help you with the other ones, but I can't promise anything. Okay, one of the reasons I want you to use CLine is because, number one, as a student, you can get it using, your student email for 1 year for free. It's a paid-for software, costs like $200. But if you get stuck on something's not working, like, wait, I wrote this program and it's saying something about a compiler, you can contact their customer support and they will help you. I've had to contact their customer support and they help me. They're good at it, okay? Because they're getting paid for that. All right, this is not like open software. Open source software like Eclipse. I personally like Eclipse better, but if I get stuck on Eclipse, good luck. Okay, I got to figure out how to do it myself. Anyway, so it's a good little, integrated development environment to use. So suppose you install it and you set it up the right way, which isn't very hard. Then we're going to create a new project. I'm calling the project whatever, CSIS45, Spring 17, wrong name, should have been 16, CS46, Spring 17, whatever. Okay, what I'm going to do is I'm going to click on my project, and then I'm going to click new, right click, then go new, and then from new I can choose to add source files and header files. Okay, and what I'm going to do is I'm going to add a couple of source files and a couple of header files. You can see them here on the left. There's a header CPP, there's a header H, header 2 CPP, header 2H, and a main CPP. So like I said, many files, and they all run from the main. So let's have a look at these different files. Ooh, high quality picture. All right, so first of all, we're going to look at, let's say, the header CPP. Okay, so you remember your function prototypes from CSIS45? Well, this is a function prototype right here. And the headers, anything that has a .h file extension, is where we're going to put our function prototypes. Okay, so I'm basically just declaring or telling the program, look, there's going to be a function called show. It's not going to return anything. It's a void, and it's going to have one parameter, int num. Okay, that's it. All right, and then this file, we'll focus on the if and def in a minute. Okay, so now this file, the header.h, is, you need to create another file called header.cpp. It's basically the same exact file name, except this one ends with a .cpp extension. Okay, what's in that one? It's your function definition. All right, so the headers contain the prototypes. The CPP files contain your actual definitions. All right, so this one tells you there's going to be a function. This one tells you, okay, well, the function is going to be doing this and this. Okay, so you don't have to include anything on top of your header file other than, well, in this particular case, I'm going to be using the IO stream and using namespace std for the cout. That's the only thing I'm going to include. Okay, C++ will automatically know that these two are linked together. I don't have to tell this one, hey, look for the header.h or include header.h or whatever like that. Okay, and then also notice there's an if and def header h, define header h, and endif. That's part of the header h. Okay, we'll talk about that in a second. Okay, but for now, you have two files. Two different files. Same name, the only difference is one is .h, the one is CPP. The .h has your function prototype, the .cpp has your function definition. Okay, now let's look at the other one. So this one, okay, this one here, I have a header 2.h, and what's in the header h? Well, it's just another definition for some other function, right? So this function, by the way, the first one, that has a void function which just has a cout of this variable num, right? We know what that means. Now the other one, the header 2, has header 2h, has a prototype for show2 int num, which is basically almost the same as the other one we just saw. And in the header 2 CPP, which is the file name associated with this header file, we have another function called show2 and with a parameter int num, and then this one calls show num. Where is show num? Well, show num is in your header.h file. That's why I have to include header.h, because this particular program right here is referring to another file where the function is located. So by just including header.h, now I have access to this function prototype and the function definition, and I can just use them. Make sense? All right, so that's what you do. You basically, if you want to have your functions defined and with prototype somewhere else, not in the code that you're using right now, you just include these headers, okay? And that might explain to you how we've been including things for the 45 class. Remember, we had to include the stdlib or the math.age or time or whatever else we had to do to generate random numbers, that kind of things. Well, all that stuff is not available by default because you don't want to suck up too much memory for your program. You only include things that you need. Okay, and Java does similar stuff too. Okay, so that's that. And then I have my main. And my main is going to be using both of these functions, and I have to include both of the header files. So I'm including header.h and header2.h. Make sense? And then I can just call both of these methods and use them. Any questions?
So you start going from left to right when you type your code?
Left to right doesn't really matter. If you just look at this stuff here, you just type them all up. Okay, and yeah, it doesn't matter, and we'll just arrange them alphabetically, and then yeah, basically bottom line is you need to have your header.h and the CPP file that goes with it before you can include it and use it. That's the only route. Yeah. Okay, so that's basically header files and how you use them. And again, I'm not going to do this to you. What we're going to do is I'm going to bundle up everything inside one class, one program. We're not going to break it down into little pieces, different header files, because debugging becomes more difficult. Okay, there's just extra syntax for you to pay attention about, and for me it's not important for you to learn some new gimmick or whatever trick. For me, more important is for you to understand the fundamental concepts of data structures, which is the purpose of this class. All right. So I already explained to you what's the header.h, how it works, all that good stuff, right? And there's some arrows in there, explanation, what's the definition, what's the prototype. Okay, now the purpose of if and def and defined and endif. Okay, and the purpose of those is to not repeat things more than once. Okay. Let's see how we have it. What's the illustration I have? Okay, so remember how my main, right? This is my main, right? The main includes header.h, okay? But then remember that header 2 CPP was also using this show function, so we had to include header.h again. Okay? So what is the purpose of if and def and define and endif? It is a way to tell the C++ compiler, don't import this thing twice. Okay, so in other words, if you have already imported header.h at some point in this program, the program has access to header.h. Don't import it again. Okay?
So in this case, you just remove it from the main.
What's that?
So in this case, to correct the issue, you just remove it from the main.
No, you don't. You would still do it the same way you're seeing this. You would just still write what you're seeing, but the purpose of this was to ensure that even if I do that, there's no duplicates.
Right. So to remove the duplicates,
You don't.
Your function had the header, and main has the
You
header.
don't have to worry about removing duplicates. That's what I'm saying, because that's the purpose of the if and def and define. That is like basically a thing that exists in the language, so that even if you have duplicates, like I do, it's okay. It will not repeatedly include things that have already been included. That's the purpose of the if and def and the define. And the file name here, I mean this header._h, this is just like a naming convention, all uppercase or the underscore and then an h at the end. That name could be kind of arbitrary, just so you know. Okay? But as you can see, there's a lot of things that could go wrong, and maybe you didn't spell the if and def the right way, or these here are not typed up the right way. And there's some mysterious errors that pop up from C++ when that stuff starts going wrong. Okay? So again, summary, the header file contains the function prototype, the source file contains the function definition. Every header file must have some file.h, must have a corresponding some file.cpp. And you must include some file h if you want to use whatever's inside the some file cpp, whatever's defined in there. And the if and def and endif is used in a header file, so the header file can be included only once in a project. Okay? One thing I want to mention is, as far as CLion is concerned, you can have a project with a whole bunch of files in there, but there can be only one file that runs the show. That's the one that has the main. And that's why CLion names it main CPP, because it's got the main. Alright, you can fix this, you can change how CLion works by changing your CMake lists. Alright, CMake list txt, let me see if I have CLion going. It's going. Alright, so this is an example program here that I have. Alright, and look at my CMake list. What's in my CMake list? Main.cpp. So if I wanted to, I could go in there and I can create a new file and I can put the main in it and I can try to run it. It won't run that file. It will. The CLion will only run whatever file is here. Okay, so those are just different things you have to do. If you want to do it manually, okay. But if you're going in there and you're doing like, okay, we're gonna do this project, new C++ source file and all that stuff, it will automatically rewrite the CMake list for you. So you don't have to worry about this if you follow the instructions that I gave you. What's up?
Do all the header files need to be in like the same folder?
Yes. Well, yeah. You do. You put all the header files and all the CPP files that are going to be working with the main into the same folder. Okay. And CLion will do this automatically. Yeah. Yep. So that's basically in a nutshell, header files, the if and def, how you include things, how you write these things, some examples. And you're going to have an assignment today that goes with this, which is one of the easiest in the semester. It really is. So it's basically, there's a PDF. There's the assignment 1, right? So you're going to create a project. You're going to add all these different files that I already had, right? Create everything I showed you. Make sure it works first, right? of course, always, and don't even write all of them at once. Just write one, test if it works, then write the rest. Just the usual business. Okay? And then, so that's the first part. Make sure that what I just showed you works, and yes, it works because I showed you that it does. But maybe yours won't. Okay? Now what you're going to do is you're going to make another header file and another CPP file that goes with it called rectangle. Okay? And in there you're going to have two functions. One is an area, find the area. The other one is find the perimeter. And I have included some preconditions in there, right? If you want to calculate the area, maybe it makes sense for the things to be greater than 0. Otherwise, you can't really talk about an area. Same thing about perimeter, right? And what's the post condition? Well, one calculates the area, the other one calculates the perimeter. Basic stuff, okay? It's just to give you practice with creating your own header file. And then once you have created your own header file, right? This is what it will look like. You're going to have a rectangle.h also. You're going to be testing these two functions, the area and the perimeter, from inside your main. And look at that, I even gave you the freaking answer. So rectangle CPP and rectangle H. All right. So yeah, and then notice that the files, before you turn it in, make sure there are 7 files. Right? There's a rectangle H, rectangle CPP that are on this list of things. And that's it. Okay? So baby project number 1. This one's not too bad. Okay? But it really doesn't have to do with data structures. So next week we're going to talk about encapsulation and really get started with the data structures business. And for this assignment, just zip up all your files, right? All the 7 files, zip them in one zip file and upload that. Unless you want to upload 7 different things. I don't care. But it makes it easier for me if you uploaded a single zip file. Okay? So that's basically in a nutshell. Week 2, week 3, just so you know, we're going to talk about more about arrays. Okay? And how you basically, you know how we have an array. Well, we're going to get an array, we're going to put it inside of a class. So I'm going to introduce you to objects, or review objects for some of you. And then we're going to bury an array inside of the object, and we're going to fix it so that we can only do certain things to that array, right? And we're going to be doing similar thing to the queues, similar thing to the stacks. A lot of the things in this class are going to have to do with arrays. All right? Questions, comments, concerns? We're good? Okay. You know my office hours. To send me emails if you get stuck. Thanks for coming. Hope to see you next time, or even before that.
Are you grading our Java steps like week by week? I'm on
Yep.
week 3. I just want to make sure I'm doing it.
Yeah.
Right.
I am going to start reading stuff this week.
Okay, cool. I just want to make sure I'm going ahead and screwing stuff up. I don't want to.
Okay. No, and you can always email it to me, and I'll
Oh, okay, cool.
Yeah.
All right, thank you.
Sure.
See you next week.
What's up?
As we go through this and I see the data management basically, I can see that one folder is going to start getting pretty crowded. Do you have a method for file management that makes it?
Make different folders for each project.
You don't have to have them all in the same area, or if you start using some of the previous objects or functions, so you have to